Hello everyone. Today we'll be learning about the RSA algorithm problem, encryption in cryptography with the subject code 18CS744. Here we'll be learning about the encryption and decryption process. Okay, we have first step is to select two prime numbers. Already they have given in a question saying that P is 17, one prime number, and other one is your Q, which is 11, another prime number. The first step is done. Second step, what we have to calculate is we have to calculate for n. N is nothing but p into q, which is 17 into 11, which is 187. Next, third step we can take it as we have to calculate phi of n, where phi of n is nothing but p minus 1 into q minus 1, which is nothing but 16 into 10, which gives you 160. So phi of n is 160. Okay, then now fourth step is we have to calculate the private key, which is nothing but your d. Okay, we have to calculate d. So e into d is equal to 1 modulo of 160 or 1 modulo of phi of n. Let us take the formula exactly. So we know we know d into 7 is equal to 1 modulo of 160. Okay, so when you multiply, always you remember d should be greater than 160. Okay, d should be always greater than phi of n. So any number with modulus of 1 is 1 only. Okay, you add another number for this, you will get 1 only. But remember, d should also be prime. It can't be a number which is divisible by more than one number. Okay, so what is that number? Let us take. Now what will you get 160 here, modulus of 1? How do you get it? Let's see. Okay, let's see how it happens. So now let's see, d should not be greater than 160. Okay, now we have to get 160 here. At any cost we have to get 160. So what value, if you multiply, take as d and multiply, you will get. So let us assume you can take from 1 2 3 4 something. So what I'm doing is I'm directly taking 21. Okay, just to show you, that's all. Okay, d is equal to 21. So 21 into 7, what will you get? You will get 147. So this can't be taken. Next, 22 into 7, so 154. So this also can't be. 23 into 7, 161. So this is almost nearing to this. So this is nothing but 1 into 160 plus 1 is your 161. So hence we can say that d is equal to 23 is our correct answer. Okay, d is equal to 23. We have calculated this. After this, we have done with 4 steps. Fifth one, what we have to do, we have to calculate c is equal to m to the power e mod of n. C is your cipher text, M is your plain text. Plain text is given to be as 88 to the power E is 7, modulus of N is 187. Okay, now we have to calculate mod for this. How to calculate it? Since it's in power, how do we calculate the modulus of this? Before we go for this, I have to add on one more point. Your public key will be given by e comma n, which is nothing but your 7 comma 187. Okay, your private key is given by d comma n, which is nothing but 23 comma 187. Okay, we have got public and private key. Okay, now here to calculate this, okay, we can make the calculation in another way, easier way. 88 to the power 4 modulus of 187, 88 to the power 2 modulus of 187, 88 to the power 1 modulus of 187. When you multiply all this, you will get 88 to the power 7, right? Now 80. Always remember one thing, if your first value mod of second value, if your first value is lesser than second value, then whatever your first value is there, that will be retained as it is for your modular symbol. So 88 to the power 1 mod of 187 is nothing but 88 only. Take 88 square, that is 88 into 88, you get 1744. For this modulus, how to do? Divide by 187, you get a value called as 41, minus 41, you get one value called as 0.7, multiply it with 7744. What will you get? Now for 88 square mod 187, let us take 88 square is 88 into 88, which is 7744. 7744 divided by 187, you get a 41, minus 41, you get a value, multiply it with 187, you will get 77 as your mod answer. So this is 77. Next, for 88 to the power 4, let us take 88 into 88 into 88 into 88, which gives you so much. Divide by 187, you get some value 32. We'll write 320692. So minus 320692, you will get a value so much into 187. You get a modulus as 131. Okay, which can also be written as 132 because 0.9 is there, right? Now multiply all this. For 88 to the power 7, mod of 187 is nothing but it's given by 188 into 77 into 132 modulus of 187. Okay, how do we get this now? Take 88 into 132 into 77, you get some value, you have to divide it by 187, you get a value called as 4783, minus 4783, you get a value, multiply it with 187, you get answer to be as 11. So your answer for 88 to the power 7 mod of 187 is 11. So you got C to be as 11. Now let us solve the same thing, same way. Let us solve for M. Okay, now we have to decrypt it. M is equal to C to the power D modulus of 187 or modulus of n, which is nothing but C is given to be as 11. 11 to the power 23 modulus of 187. So how can you take 11 to the power 23 into picture? We will find it out. Par 1 plus 2. 1 plus 2 is 3. 3 plus 4 is 7. 7 plus 8, you take 8, 12, 13, 14, 15, 15. Again add another 8. Okay, what will we get? 8 plus 8 is 16. 16 plus 4 is 20. 20 plus 3. Correct? We've got 23. Okay, so this can be divided like this. I'll show you here only. 11 to the power 1 mod of 187, which is nothing but 11. 11 to the power 2 mod of 187. Okay, where 11 to the power 2 is 11 into 11, which gives you 121. 121 is less than 187, right? So we take it as 121. 11 to the power 4 modulus of 187. Okay, we are taking here 11 to the power 4. What is 11 to the power 4? So much divided by 187, right? We've got a value 78, minus 78, right? We have got some value and multiply it with 187, you will get an answer as 55. So this answer is 55. 11 to the power 8 modulo of 187 is given by 11 to the power 8. What is 11 to the power 8? Right, divided by 187, you've got answer to be as 11,46304 minus 11,46304. If you do, you've got an answer. Multiply it with 187, you will get an answer to be as 32.9, which is 33. Now 11 to the power, we can take this 23 as 11 to the power, we are just taking it like this. 11 to the power 1 is 11 into 121 into 55 into 33 into 33 modulo of 187, which is nothing but, let me multiply this all value. 11 121 into 55 into 33 into 33. What we get? We get some value divided by 187. You get a value called as 426311 minus 426311. You get a value called 0 into 187. You've got 87.9, which is nothing but 88. M is 88, right? Did you get the same M as in your question? So our encryption and decryption is done correctly. This is how you have to do RSA problem. If they ask encryption, they may ask it for 4 marks, and if they ask encryption and decryption together, they may ask it for 8 or 10 marks. So this is also one of the important problem in your module 2. So please do note it down correctly and learn how to do modulus. This is very important. Basic thing in making is splitting the power. Okay, if they have given 23, split that power into single so that your modulus function will be done very easily. Or you want to do it directly and see. If you want to do it directly and see also, you can see, but try doing it in this method gives you an easy way of solving the problem. When you do it directly, you will get it in into 10 power 23 values. So this value you can't find modulus very easily. That is the reason what we will do. We will split the power into smaller units and we will identify it.